The purpose of this lesson is to learn about performance issue causes, how to monitor the server, system variables and how to view them, logging and how to configure it, performance tuning, and denormalization. Most of the performance issues that you will experience are caused by insufficient hardware resources, a large number of connections. The database design itself can actually cause it, so if you have a poorly designed and poorly implemented database that's either under or overly normalized, that can also cause issues. You could also have inefficient query design, so we could use an overuse of subqueries instead of joins, using natural joins instead of explicit joins, and also incorrectly configured MySQL settings. One of the things that a DBA needs to do is to monitor the server, and the way that you do this is through the MySQL workbench. There's actually a utility called server status, and the server status will allow us to view information about the server and the hardware, and it will also allow us to see things like the system directory, so we can actually see where the data directory is, where the error logs are stored. We can see information about client connections. We can see who's currently connected, what kind of threads that they're running. We can kill those connections, and we can also kill off a query. So if I have a query that is running and is taking a long time to actually complete, and I find that that query is actually using a large amount of system resources, I can kill off that individual query without affecting the other ones. I can also view the system status and the system variables, and we're able to see those through the workbench and actually be able to figure out where things are. So we can find out where the data directory is, and we can find out where the configuration directory is and things of that nature. We can set system variables by the workbench. It is possible to edit the my.ini file directly from the workbench. One of the things that you'll see is that the initial location will be invalid, and this is because it's looking for an older version. We actually have version 5.6 installed, and for some reason it's still looking for version 5.0, so I'll show you how to fix that. There's also a GUI-based editor for the options file, so I can actually go in and I can edit the file directly through the GUI, and what this does is it allows me to edit it without having accidental mistakes. The only problem is that it will not work in systems where the user does not have direct access to the data directory. So if I'm on a system like Mac or Linux or Unix system where I have to raise my permissions via su or sudo, then I will not be able to access it through the GUI. So I opened up MySQL Workbench, and I am in my local instance of MySQL. And on the left side, if I go to Management, I have an option over here for Server Status. The server status will show to me the connection name, so it's local master, which is the same thing as what I configured in the Home tab. It will show to me the name of the host that the server is on. It will show the socket, what port number it's using, what version of MySQL is being used, what platform that you're on. So I can see by this that I'm on a 64-bit platform. Where your configuration file is located, so this is the actual path to the my.ini or my.cnf file. How long the system has been up. And this is not constantly updating, so I may need to refresh this. So just be aware that the information is not necessarily live. You have to refresh it. If you leave this tab open, it may not be live data. This also shows to me the features that are installed, so I can tell that I have the performance schema installed, but these other ones are not. They're all turned off. If I turn those on, then they would actually show up in the system status here. I can also scroll down and see things like the server directory, so I can see where the base directory is, where my data directory is, how much free disk space I have, where plugins are stored, where our temp directory is, and then also our logs. Now the logs, the error log is turned on. That one's by default. The other two are turned off by default. We have the general log that logs everything. So anytime somebody logs in, logs off, makes changes, that all will get stored in the general log. And then also the slow query log is here, and what the slow query log is that if a query takes more than 5 seconds to process, it would actually it would actually put it in the log here. The problem with these two being turned on is that you will notice that the system will run very slow with them turned on. It also will show to me down here if it is a replication slave. In this case, it is not a slave, but on a slave, it would actually show to you that it is a slave and information about where its master is located. I can also see information about authentication. So am I using SHA-256 password keys? No, I'm not using keys, so in this instance it's not available. And also if I were using SSL for a secure encrypted connection, that would be listed here. On the right side, I can see that the server status is that the server is running. We are using 23% of the CPU. Right now there are 5 connections to the server. I can see how much traffic is being used, how efficient the system is being. I can see how many select statements are being performed per second. So if I have hundreds of users performing select statements, I would actually see those. How many reads per second, how many writes per second, and also how much buffer usage the system is using. So how much memory is the Nodb database engine actually using at this given point in time. Now be aware that this is not necessarily how much of our overall memory is it using. It's how much of the memory that is allocated to MySQL is it actually using. On the left side here I have some other options, so I can see client connections. I can look through this and see all of the users that are currently accessing the system, and I can see what kind of processes they're using and what kind of threads they're using. So if I have a user that's logged in that is causing me to have a large amount of queries, or there's something going on that I don't believe that they should be in the system, I actually have the ability here to kick off that individual user. So I can right click on them, I can kill their queries, and I can kill their entire connection. Now what this will do is if I kill their connection, that does not prevent them from reconnecting. It just simply kills this particular connection or this particular query. So if I have a particular user that is running a query and that query is taking a large amount of time, or if that query is causing my system to be slow, I can kill that one individual query and everybody else is left unaffected. What they will notice is that when I kill off a query that's using a large amount of resources, their queries will actually perform faster. I also have my users and privileges that we used before, so I can create user accounts. I have status and system variables. Now what this is for is, in a prior lesson I was trying to find out where the data directory was. And all of that stuff is located in the variables. And I have 2 types of variables. I have status variables and then I have system variables. So the status variables are things about how the system is actually performing right now. What are the statuses of things like, is Nodb enabled? Is MyISAM enabled? What kind of transactions are they performing? All of that stuff is in status variables. My system variables, these are going to be things related to how the server is actually configured. So things like our server ID and our binary logging, that kind of stuff is stored in here. They are organized by category, so if I want to see something about Advanced General, I can go down through the list here, or if I want to see everything, I can just simply click All. And I can see from the list here that our base dir is right here, that's under program files. And then if I come down, I can see data dir. So when I did my show variables statement in a prior lesson, and I told it to show me the variables where variable name is like something that ends with dir, I got these entries that ended in dir. It didn't matter what the beginning was, but they just simply came out of this list. Other things that I have access to are the ability to start up and shut down the system from here, so I can stop the server and restart it. Be aware that in some systems this may not actually stop the actual process, so you may have to manually kill it through Task Manager or some sort of process monitor, or you may have to actually stop and restart the services through the services control panel. I can see the server logs, and the error log is enabled on this computer, but the general log and the slow query log are not enabled, so I would have some more tabs up here if they were enabled. The bottom one is the options file, and what the options file is, this will actually allow me to make a change to the my.ini file or my.cnf. The problem is that by default this is looking for the wrong location for that file. So when I bring this up, it'll give me a message to the effect of the configuration path is invalid. It's going to create a new file, and you have to click OK on it. But all of this stuff will be blank because it's looking for a configuration file that doesn't exist. So the way that you fix it is you actually have to modify your connection. So I'm going to right click and edit my connection. And up here at the top you have 3 tabs. The third one is System Profile. And what you want to do is you want to browse for the configuration file. You want to browse to wherever the my.ini or my.cnf file exists. The problem is that in Unix and Linux systems you may not be able to browse to that path because the user may not have permissions to read that folder. So what would happen in that environment is you have to configure it manually from the command line, and you'd have to use sudo commands to be able to do that. You cannot access it here if you're going to have to use a sudo. Alright, so if I come back here, this is a Windows computer, so I actually have access to this file. And what I can do is I can go through the file, and all of the settings that I could have configured in the my.ini file, doing that through a text editor, I can do that all here. Alright, so I can do things like changing my data dir. I can scroll down and I can change the storage engine type. So if I wanted to make it a MyICM instead, I could. What kind of SQL mode are we using? All of the same stuff that is located in the configuration file is located here. The nice thing with this, though, is that if I make a change here, I have less of a chance of actually causing damage to it, because I'm not going to be directly editing the file. I'm just simply editing a field in here, and I'm letting the system do it on its own. The one in particular you need to pay attention to is on the logging tab. I have my binary log is listed right here, and I could change the name of the log. Remember though, once I change this, when I'm done I have to apply it, but then I also have to stop and restart the MySQL service. This binary log will not take effect until I save it and stop and restart the service. Now I can also enable and disable other types of logging, and those are both going to be done through the my.ini or my.cnf configuration file. And when I go into the options file editor in Workbench, you will see that I have different sections that I can fill out. If I actually go into the my.ini file, I may not actually see those sections in there. So it also does another service for me, which is to make it where I don't have to remember what the name of those sections should be. So things that I can configure are things like the location of the system and error logs. I can modify what severity level would actually get logged. I can set how many days that these files should be retained, or how often they should be rotated. And so I can actually configure a process, which is simply a saved query called a stored procedure, that I could set to schedule rotating or truncating the logs once a month. What's going to happen is your log files, if you have them enabled, they will continue to grow in size, and every time something writes to it, it has to read the entire file in and write to the end of the file, and then it commits it to the drive, and then it exits. So what will happen is as the file gets larger and larger, it will take longer and longer to be able to read and write the data to and from the file. So when I'm looking in the options file here in the Workbench, I can go down through and I can look at some of these, and I have my maximum number of binary log dump events, maximum binary log cache size, the log size itself I could set. So I actually do have the ability to configure how much stuff is saved here. The thing is that some of these I don't necessarily want to do through the configuration file. A stored procedure will do the same thing, but the problem with these is that the settings that are in the configuration file only get applied when the service starts up and it reads in the configuration file. So if I have it set where the binary log can only grow to a certain size, and it only processes that when the service starts up, and if I have a system that I don't ever shut off, then that will never actually get processed. Whereas if I create a stored procedure to do the same thing, then my stored procedure can go through and it can truncate the logs, and I have more control of how often that actually works. over time your system is going to get slower, and the reason for it is one is going to be additional resource requirements, because as your database grows it's going to require more memory, it's going to require more hard drive space. So what we're going to start doing is this process called performance tuning, and the purpose of performance tuning is to take our system and cause it to not slow down so much. So essentially what we're doing is we're going to try to do some things to make our system run faster. So what I want to do is I'm going to make some changes to the system, and I don't want to make a whole bunch of changes at the same time, because if I do and something doesn't work, or even if something works great, I'm not necessarily going to know what the change was that caused the outcome. So what I want to do is I only want to change one setting at a time, stop and restart the service, use it for a little while to make sure that it works or doesn't work, or if it actually does increase the speed. That way I can start getting a feel for what things are actually working well with my system. It also allows me that if I break something when I make changes to it, if I only made one change, then I know that that's the change that broke the program, and that's all I have to do is go back and undo that change and put it back to the way it was before, and that'll fix the issue. So the system allows me to use what are called set global commands, which these are going to be queries that actually get issued in a MySQL query window. And a set global command is a temporary setting for that particular variable. Alright, so in a prior video I showed you how to use the set global command to set the replication master and a set for the server ID. If I don't put that into the actual configuration file under the MySQLD section, then it will only be effective until I stop and restart the service. Anything that's in the MySQLD will be permanent. That kind of stuff, every time you restart the service, it will get started again. So if I set my ID as 2 using a set global command, the next time I restart it's going to put it back to 0. So I want to make sure that I actually use the set global to test it, and then if I find that that setting works, then I want to put it into my configuration file in the MySQLD section. One of the things that we need to do is we need to perform tuning of our database engine. And our storage engine by default is going to be Nodb. It's the default database engine for version 5.6. The most common performance enhancements are already configured during the installation. So when you actually perform the install, it will ask you what the purpose of the server is. And if it's a development machine, a server machine, if it's replication, anything like that is asked during the installation, and it will automatically configure these settings for you. However, some of the settings can and should be changed, and the purpose of these is to increase the disk read-write activity and memory usage. Actually, what I want to do is decrease those and increase the effectiveness of those. I want to increase the number of connections that are allowed at a given time, because I may run out of connections that are available. I may want to increase the size of the log files, because at some point I may run out of a log file and I get errors. I want to decrease the amount of time that is required to commit data to the disk, and I also want to decrease the I/O load. All of the following settings that I'm going to show to you are going to be done in the my.ini or my.cnf file, and most of them will be under Nodb because that is our storage engine that we're going to be using. A couple of them will be under advanced and other. So what I'd like to do is to discuss with you some of the settings that are located here. Nodb buffer pool size is designed to increase or decrease the amount of memory that should be allocated to individual processes. You want to set this as high as possible so that way all of your processes use memory instead of the slower disk cache. The problem is you want to make sure that you don't set it so high that you run out of memory for the server, and you don't want to set it too low that all of your queries and all of your processes and tasks will run on the hard drive. We don't want to use swap space if we can help it. Nodb log file size, by default there are 2 log files, both of the same size, but they start really small. They start at 48 megabytes in size. You want to increase those at least to 512 megabytes for a gig total. This gives more room for writing to the log for write-intensive applications or queries. Max connections controls how many connections can be made at one time. The default is 151. The issue is that this is not necessarily user connections, it is how many connections to the database do we have. So one application could possibly have several connections. If you're getting messages that say too many connections, you want to increase the number of allowed connections. The downside of that is that too many connections will cause the system to become unresponsive. So you want to find the happy medium, so enough connections that your users don't get errors, but not so many that you run out of resources. So what you want to consider doing is, for any applications that are interfacing with your MySQL database, you want to use a connection pool instead. And what a connection pool is that it's an interface for an application to be able to talk to the database where it actually only gets one live connection. But what happens is it will cause any other threads or processes that try to create a new connection to use the one existing connection. The Nodb per file table, this designates whether the data and indexes get stored to a shared namespace or if they actually get stored out to separate IDB files. The default for this is turned on. The data and the indexes are stored in the data folder in separate files. And if you change this, it will cause no performance increase unless you have a huge number of tables. Then you may want to consider putting it in the shared namespace. But for the most part, we want to leave this alone. We want every table to be stored in its own file. The Nodb flush log at transmit commit, the default setting is 1. This is the best for the master where the data security is important. It increases the hard drive reads and writes, so it'll make the system a little bit slower. Our slaves can be set to 0, but essentially what this does for us is that it will write data to the files, but it will not remove it from memory until it's sure that it's actually been committed to the hard drive. Now, like I said, it'll cause the system to be a little slow, so we have another option which is 2, which is a medium speed. It will actually write to the hard drive and memory, but it won't check to make sure that it actually wrote to the hard drive correctly. What will happen is we get a little bit of speed increase, but the system doesn't actually verify that the files are there, which means that there's a possibility we may not actually have all of our data on the hard drive before it gets committed from memory. The Nodb flush method, this controls how and when the data and the logs are flushed to the disk. Now the fdatasync, that's the default method, but it's fairly slow. It verifies all the data that's written to the drive before it flushes it from the cache. There are other ones that are available. We have odsync, which is not used for Nodb because of incompatibility, but the other one that actually is used is odirect. Now what this does is it directly writes all of the files to the hard drive without verifying them. So it's very fast, but there is no data security, which means we have no guarantee that the files are written correctly. There are a couple of other options called little sync and no sync. Those are for internal performance testing only. They're unsupported and should never be used in a production environment. The Nodb log buffer size, this controls the size of the log buffer. So in other words, how much memory is allocated per transaction. The default is 1 megabyte, which should be okay for basic queries. So doing things like updating a person's name, address, telephone number, things of that nature. But any queries involving what's called a blob or a binary large object will encounter a buffer overrun because you're trying to put in more information than what is actually allocated to that particular query. So if you encounter the messages where you have too much data trying to be put into the query and you get a buffer overrun, then you just simply want to increase the size. There is a status variable called Nodb log weights, and it should have a status of 0. If it doesn't, there's a problem. So if the status is anything other than 0, you want to increase the size of the log buffer. You have some other settings that you can also set. You have a query cache size. This is disabled by default in newer versions. You can disable the query cache size by simply issuing a command, which is query cache size equals 0. It's actually in the configuration file. We can turn off the binary logging. We need the binary log on the master. You don't necessarily need it on the slaves unless you ever plan on one of your slaves becoming a master. So if we want something like failover, where if our master dies, then we automatically bring up one of our slaves as the master, they have to have the binary log enabled. So the binary log slows it down a little bit. If I know I'm not going to use one of my slaves as a master in a failover scenario, then I can disable the binary log on those computers and it'll free up a little bit of resources. The better way to do this is to eventually purge the logs. What happens is the binary logs, they're retained indefinitely and they just simply continue to grow. And they'll grow to a specific size and then they will roll over into a new file. So what you may want to do is, instead of disabling the binary log, is to purge it. And you can either purge it by file name. So if you do the first one that says purge binary logs to base name dot and then 10, it would purge anything after base name dot 10. So 11, 12, 13, those would all get deleted. You can also purge logs based on a date. So I could state here that I want to purge all the logs prior to July 13th, 2015 at whatever time. I can also automatically expire them. This is going to be in the configuration file. I can expire the logs after a certain number of days. The issue here is that, remember I said that anything that is in the configuration file only gets read in when the system actually starts up. So if I'm not regularly restarting the services, then it's not necessarily going to delete the files. So you're better off to manually purge them or put them in a stored procedure. There is another setting to skip the name of the DNS resolver. So it's skip name resolve. Essentially what happens is if I use a host name for my master or for queries, then what happens is every single query will have to perform a DNS lookup to find the name of the computer and its IP. So if I have to do a lookup for every single query to find its IP address, I'm also going to cause the system to slow down because it's going to have to perform lookups through DNS, and I may not want it to do that. So what I can do is I can force it not to do a DNS lookup, but if I force it not to do a DNS lookup, then I have to use the IP address for all of our statements instead of the host name. Now, like I said, those settings are going to be in the options file, so if I scroll down, you'll see things like our buffer pool instances. These are all the Nodb settings. If I come down further, our buffer pool size by default is 266 megs. We want this thing to be at least a gigabyte in size, if not larger, depending on how much memory we have available to our MySQL instance. Our log buffer size, notice it's 4 megabytes. I mean, that's rather small amount of space for our log buffer. Our log file size, maximum size is 48 megabytes. We want this thing to be at least 512 megabytes in size, so that way we get at least a gigabyte worth of log file. So all of our settings are inside of here as to what size they're going to be, how many undo logs. All of this kind of stuff is located in here. So you have the option of either doing it through the workbench, through the option file, or to do it through a text editor and modify your my.ini or my.cnf file directly. Now, all the things that I just showed to you are things that you can do to make the system itself run a little bit faster, but more times than not, the problem for a database server running slow is the way that the database is designed and the way that the queries work. So we also have to do this process called denormalization. In a prior lesson, I taught you how to normalize a database and that we're supposed to get everything to third normal form, and that fourth normal form is the most perfect environment, but it's not really realistic because it causes too many queries, too many lookups, too many cross tables. And so what happens is when we get our database into third normal form and we think that everything is great, it may not necessarily be the best way to handle our database. Sometimes we want it to be in second normal form. And so what we're going to do is we're purposely going to denormalize the tables. So what I want to do is I want to prevent somebody from making a database that it has to keep doing a whole bunch of different lookups to get the information out of the database. So what I have to do is I have to look at how the queries are going to be constructed. I have to ask the users, what kind of information do you need regularly? And then I need to design the database to handle that for them. So I may still need a table to keep track of a student, and a table to keep track of classes, and a table to keep track of the grade that students got. But if I find that the users are regularly trying to come up with a table where they're trying to pull reports out of this database table, then I may find that I need to make another table just for the purpose of making it easier on them to get data out of it and to increase the speed of the system. So for this example, imagine that I have these three database tables. I have student that has an ID. Each student has a name, telephone number, address, and birth date. I have a table that has our classes, and each class has an ID and a name and a credit hour and the location ID, the date and the time. And by the way, class is a reserved word, so I really couldn't use it. But for this example, let's leave it alone. Then I have student underscore class, and then each student class has a student ID, a class ID, and a grade. So what I can do is I can store for student number 300, they took class 120, and their grade was this much. So what I would have here is these two columns would actually be our primary key, and if I told you a student ID and the class that they took, then you could tell me the grade that they received. Now in reality, you'd probably have something like what semester they took the class or something else in here also, because if they retake the class, we need to keep track of how many times. But for the sake of this one, I just want it to be a simple example, so we're going to leave it the way that it is. So the problem is that if I want to get a report that has the student's name, the name of the class, the number of credits they received for the class, the grade that they received, and then their total credits, then I need to perform a query on three tables. So what I'm going to do is I'm going to select the student.name, class.name, class.credithour, student class.grade, and then I have to have a computed field here where we figure out the number of credit hours for the class times the grade, and then we know how many credits they received from these three tables. And I'm letting it do a natural join, which, by the way, natural join is fairly slow because it has to do a cross product of all of these tables, and then it has to narrow the information down based on whatever my where statement is down here. So I'm pulling information in from three tables, and I'm matching where the student ID is equal to the student ID in our class table. I'm sorry, student class table. I'm matching where the class ID matches the student class ID, and I'm looking for one particular student number. And so what happens is the system has to load all three of these tables. It has to do a cross product of all three of these tables. So however many rows are in here times however many rows are in here times however many rows are in here, and I end up with a new table that has all of those rows, and then it starts narrowing it down, so where it matches these two things and where this matches and where this matches, and it has to start at the top of that resultant table and go through one record at a time until it finally finds all the information that it needs, and then it presents it back to me. Well, if I have millions of records in this table, and if I have millions of students, I have hundreds of classes, I have millions of grades for those students, this is going to be a really big table being presented back to me. And then the system has to perform three lookups. It has to go through the entire table to narrow it down, and it's just a waste of resources. So what I want to do is I want to denormalize this particular layout, and instead what I'm going to do is create a brand new table that is there just for the purpose of maintaining the student information. Alright, so what happens is in my denormalized version, I have a table that I'm going to call student grade, and then this table has the student ID as part of our primary key. It has the class ID as part of our primary key, and then the rest of this stuff is not the key. So now what happens is the class name is not dependent on the whole primary key. It's only dependent on part of it, so it doesn't match third normal form. But the purpose for this is that now I store the student ID, so the student ID number 123875 took class 120, which was Intro to Programming. It was a 3 credit hour class. He received an A, and so he received 12 credits. So what happens now is we store this permanently. It's no longer a computed field. So what we're going to do is we're going to write the data into two different places. So I can do this one of two ways. I can leave the database the way that it is and simply add a new table, and I have to modify whatever program is updating the database, or I can create some triggers that if somebody writes something into those other tables and it's enough information, then it will actually put the data here. Now the denormalized example though, now I go to a select statement that just simply selects the information from the table. So I could effectively just simply select everything from student grade where the student ID is equal to this. So by doing this, I denormalize the database, I denormalize this particular table, and I cause it that when somebody performs a lookup, that lookup will run faster. Now it will take me longer to actually update information in the database because now if somebody updates a grade, I have to update it in 2 locations. But the purpose of this is to actually make it where when somebody does a lookup, that part runs faster. In this lesson, you learned about the causes of performance issues. You learned about server monitoring. You learned about system variables and how to view those through the workbench. You learned about logging and the performance decrease that those cause. You learned about performance tuning and certain settings that you need to set in the configuration file to cause the system to run faster. And you also learned about denormalization, where we take a database and denormalize it to make it where it's faster for lookups.